An associate professor at North Central College is taking part in a long-term experiment at Fermilab that could change the face of physics. Dr. Paul Bloom is one of nearly 200 scientists from 33 institutions in 7 countries involved in Fermilab's Muon G-2 experiment, a project over 20 years in the making. The experiment is named after the particle being observed, a muon.
It has electric charge. It's about 200 times heavier than the electron. What makes it really different is that it's unstable, that it decays after a while, which means it literally ceases to exist and turns into some other stuff. The Fermilab accelerator complex can create those muons and create them at very high speeds so that they are moving very close to the speed of light.
With the muons flying at high speeds, Fermilab needed help from North Central College to track the particles.
Every institution had, contributed to a specific thing. A lot of bigger institutions had multiple responsibilities. We took on this one responsibility that reduced the uncertainties associated with measuring the trajectories of charged particles that fly through the detector.
Bloom detailed the precision needed to measure a muon, 0.20 parts per million to be exact.
Suppose you wanted to measure the distance to the moon. The moon is about 239,000 miles away. Imagine you can measure that to a precision of about 250 feet. That's what 0.2 parts per million means. That's what we set out to do. That's what's necessary in order to learn what we want to learn from this experiment.
On July 9th, Fermilab completed its 3rd round of data collection for the experiment. Scientists have moved to analyzing all the data they've gathered, with the goal of having the most precise measurement by 2025. Bloom isn't the only North Central representative involved in the experiment. Since 2017, he's invited students like super senior Andrew Garcia to help him with the project.
So far, I've been just going through it, just learning the instrumentation, just how all the circuitry works and stuff. It's a really cool experience to be a part of such a big project like this, and to be able to have my own part in it. Even if it's a small part, it takes all these little parts together to make a big project come together.
Although the final results of the experiment are years away, Bloom was honored to take part in a project asking fundamental questions about how the universe works.
We're asking nature, tell us what this thing is doing. If they don't match, it means we're missing something. Is it another particle? Is it an unknown force? And we don't know. We literally don't know what we don't know. That mismatch would tell us maybe there's something new going on out there. And if we're lucky, it also gives us hints about where to look next. This kind of thing doesn't happen very often.
Reporting for Naperville News 17, I'm Will Payne.